Hi there, guys. So today I'm going to be introducing a little bit of what Cartesi has been doing by going through a little machine learning example model being processed inside of the ecosystem of Ethereum, still using Python. So I'm going to go through the example and then show you how I'm going to be doing minor changes to adapt it to the ecosystem. And then I can explain to you a little bit how that is possible. So here, I have a model already loaded inside the Pico file. I'm not interested in going into the details of actually training it, just actually loading and being able to use it. And there's nothing so special about it, right? Like I'm loading a file, I'm calling a function on that module, and I'm grabbing information from the console to create a sentiment analysis on that. By the way, that model, I forgot to mention, it's a naive-based model trained on the Twitter US airline sentiment data set that is publicly available. So to use that thing, we basically just go to our terminal and send a message. In this case, God Summit is awesome. And I think it is a positive sentiment, I guess. But then, can we bring it to the blockchain? Can we bring this kind of code to the blockchain environment right now, such as it is? And many would say just no. You would go through a lot of hoops to actually make it possible. But it actually is possible right now. So here I kind of sectioned it in two pieces. I don't know if you can see that. I guess it's sort of readable. And that is because if I were to just actually use it from the terminal, that code would be fine. But then we want to be able to use it over and over again by interacting with the smart contracts on Ethereum. So I need to start interacting with some kind of API. So that's what we see here. There is some request being done to some kind of REST API. I won't go too much into detail because I think that would overload you with a lot of information. But basically, at the end of it, we see a request being done to a notice endpoint, and that's what we are creating. A notice is a log that is verifiable. You can have a Merkle proof that the notice is correct on chain. And that notice can be any payload. So it can be a binary data, a string in this case, and it can be a JSON file. You choose it. And here is our little bit of snippet of code from the previous example. So here's just the piece where we are encoding the result. Doing the analysis and then encoding the result. And then for the other half of the code, there is like a main loop with a few things going on. But then we can see again the old piece of code where we are just loading the Pico file and calling that handler that we saw previously. And that is all that you need, really, to start interacting with the blockchain. So how does it look like? How does it feel interacting with this code right now? So it could go in a smart contract, call that contract, here represented by the custom dApp variable, and call add input to the rollup framework of Cartesi. And you just send a message. Or you could do a JSON RPC call as well. Then you're going to grab our CLI. We're going to check for new notices. And you're going to see that a new notice was created with a positive feedback. But that's simple. That's not that impressive. What becomes impressive is, as inside the smart contract development environment, meaning could be any other contract, you could go back to that contract and call a validated notice function and check whether or not that positive thing that was computed outside of the chain is actually valid or not, meaning it is trustless still. And how is it possible? How can we make it so? So Cartesi is an app-specific rollup with a Linux runtime. I'm not going to focus on the Linux runtime first. So the Cartesi machine is a RISC-V emulator that the researchers of Cartesi made a specific effort of making it deterministic. And that is the heart of the solution. And that emulator is running off-chain on your computer. That's what was able to run the machine learning model that could take hundreds of thousands of CPU cycles. So it's not really able to be processed fully on-chain. And then you also have a mirror of the emulator on-chain for disputes. But only this is not enough to explain how everything comes together. You need to understand that, this is a very simplified image, by the way, the whole machine is actually Merkleized. So at any given point in time, if you stop the machine, you can have a Merkle root of the state of the machine, meaning that in between executions, you can check whether or not you agree with the other parties on your rollup, whether or not you are really in agreement. And if you are not, you can find exactly where you disagree, meaning the CPU cycle, and you can revert back to Ethereum to check whether or not who is telling the truth or who is correcting me. And as an overview, you can see that here's how it looks like overall. So the little box just below, I don't have a pointer right now, but it's that backend. That is our machine learning model being run inside the Linux environment. And that is the Cartesi machine inside the Cartesi node. And all the information would be going through the Ethereum blockchain, processed off-chain, and can be verified back into the Ethereum chain again. And that's how everything comes together. Did it make sense to you guys? I'm open for questions now. Because really, what Cartesi is doing here is giving you back the ability to have a full VPS inside the blockchain ecosystem. So it means that you can code in any language using any toolset that you're already used to inside this enclosed environment. Thank you, guys. Yeah, go ahead. So, okay. So he just asked me, what does it mean to verify data? So yeah, we have two main types of verifiable data. One is the voucher that can become an Ethereum transaction. The second one, the notice. I guess that's the one you're mentioning, right? Because of this slide over here, I guess, referring to, right? Validate notice. Yeah, so what this does is, because we have a Merkleization of the whole machine, you can tell exactly where in the memory, meaning the drive, like here, you see there is an input and output over there. So we created drives to encapsulate the idea of how to communicate with the Ethereum blockchain. So a notice will be created inside this output drive. And because you're you're agreeing in the, about the Merkle root of the state of the machine at all points in time. So it's an optimistic rollup, right? So as soon as you pass the settlement period, you agree on the state of the machine. So from the state of the machine, from that Merkle root, you can create a Merkle proof about anything inside the machine itself. And in this case, the notice is just a piece of data inside of the output drive. So you can create all the, you can collect all the sibling hashes all the way to the Merkle root of the machine. And with that on-chain, you can verify quickly whether or not that information is correct in the sense of generated. As long as it is deterministic, right? This is a deterministic machine. So let's put it in another way. Maybe the computation is wrong, but everybody would be wrong on the same page. That is, I'm not verifying that the code you created is correct. I'm not doing formal proofs of the correctness of your code. I'm just, this is just a method to agree on a certain computation between multiple parties and use Ethereum as the final judge in case there is disputes. Make sense? Any other questions? No? Thank you.